come up with an equation given a graph. From our work here, looking at the first equation, number 7, the first graph, number 7, can you see that there has to be a +2 on the end because of where the asymptote is? It's already at +2. So you know there's going to be a +2 at the end. Now, at 0, what number does it go through?
3.
And how high is 3 above our bottom end of 2? Okay, so that means that the A value has to be 1. Because remember, that's the initial value. And the initial value is not 3 here, although it appears to be 3. It's how high above the base. And the base is already up to 2. So how much higher is it to 3? 1. So that means we have 1A, so we really don't need to worry about putting a 1 there. And it's going to be a to the x plus 2. The question now is, what is a? Well, let's go over to what happens when x equals to 1. What value do you see there? When x equals to 1, what does the function go to? 4. So we know that a to the 1 plus 2 is equal to 4. A to the 1 is just a, so a plus 2 is equal to 4. So if I subtract 2 from both sides, a must be 2. So we're looking at 2 to the x plus 2 there. That should be a pretty good representation of that. And the answer says 2x plus 2. Okay, how did I get that? You guys okay with how I got that? No? Okay. We should look at a piece of graph here. First thing I noticed on number 7 was that I had an asymptote here. That's at 2. Can you guys see that much from the graph? It's the first thing you're going to look for. That means that somewhere on the back side of my equation must be a plus 2. For the same reason as it was on 5 and 6, right? Okay. Or 5 and whatever it was. 5 and 6, yeah. Now, so we're really working here. And you see I have an asymptote that goes through like this. If this were my base right here, how far away is this? That's 1. So that means the initial value is 1. It doesn't mean the initial value is 3. That means it's 1 away from the base. Because if I was to take that plus 2 off of the end, it would put everything back down to where it's supposed to be. So that means that A, not A, the number in front of A, the coefficient of A, is 1. The coefficient will be the distance between the base and the y-intercept. Okay. So I already know that it's going to be 1 times a to the x plus 2. The plus 2 comes from the location of the asymptote. The 1 comes from distance away from the asymptote to the y-intercept. Now, to find out what a is specifically, I go choose a point that I can see. When x equals to 1, what is this value right here? When x equals 1, what does y equal to? 4. Okay? So, when x equals 1, I have 1 times a to the first power plus 2 must equal to 4. These ones don't need to be here. This is simply a plus 2 equals to 4, so a has to be 2. Plugging in the value for a back in here, I can say now 2 to the x plus 2 must be my function. That's a funny looking x. So that's how you find the function. We can try it again one more time with number 8. Erase this right here. With number 8, where's the asymptote? Okay, -1. So we know on the back side there's going to be a -1. Okay. Now it looks like it's going right through 0, 0. How far away is the x-intercept from the base? Again, 1. Coincidentally the same as the last one. So we are looking at a to the x times 1 up front minus 1. So let's put in the value of 1, right? So we have 1. What is the value of 1 for x? 1. So we have to point 1 comma 1. So when we put in 1 here, we get a to the first power minus 1 is equal to 1. Add 1 to both sides, and lo and behold, a is 2. Okay, again, that's a coincidence, you guys. A can be any number. It happened to be 2. So what we're looking at here is 2 to the x minus 1. play with the rest of those on the front page and on this page in the book here, 433, 1 through 77, there are some examples of graphing and talking about questions of graphing and maybe answers to questions like this, a bunch of good stuff. But there's also another section in there, which I have another handout for, because this stuff also shows up in this section. And I want us to be able to do that. Last week. You got one, Vina? All right, on this information, these are some of the things that will arise when you're trying to deal with these exponential functions, because you're going to be putting in values perhaps, and you're going to come up with some exponential equations. They go together, not necessarily exactly together, but they're certainly in the same section of this book. So I want to be good at solving some of these things. And it only takes a real quick moment to notice that if I have some x, well, that's the wrong answer, sorry. If I take some base a, and I raise it to the x power, and it happens to be equal to a raised to the y power, what does that say about x and y? They have to be the same. And that makes sense, right? If I raise, say, 2 to the third power, and it's going to be the same as 2 to the x power, well, 2 to the third will be the same as 2 to the third. Not 2 to the fourth, 2 to the fifth, but 2 to the third. So in a sense, you can drop the basis and say 3 equals to x. Okay, it's kind of the way you do this. So if you take a look at number 1, the motivation behind this, well, let's write number 1 and take a look at number 2. Number 2 says 5 to the 3 minus 2x is equal 5 to the minus x. So from that equation right there, what's the second equation you can come up with? Well, this means 3 minus 2x is better equal to minus x, right? Since the bases are the same, you can equate the exponents and solve this by adding 2x to both sides to get 3 is equal to x. Then you come over here, and what can you do here? Not 1.
0.
Who said 0? Yes, because 4 to the 0 is what? 1. Therefore, 4 and 4 are the same base. You can drop them and say 2x plus 3 is equal to 0. Now, the motivation to change that to a 4 is probably what you're questioning right now. How did you do? Wow, where did the 4 come from? 4 to 0, where did that come from? What I had to do was write both sides with the same base. And there's not a whole lot I could do over here, but I recognize that 0, 4 to the, anything to the 0 is 1, so why not make it a 4? Because I needed 1. That's where that came from. And then from here on down, it's a relativity. You get x equals to minus 3 halves. I'm sure you guys can handle this, right? This is beginning algebra. Let's move on to number 3. This is 3 to the 1 minus 2x is equal to 243. That's right. I think we saw that one earlier, didn't we? And that makes life a lot better, because what can I do with the 3's? Equate the exponents. You can double check this if you like. X equals to minus 2. If I put a minus 2 in for x, this will be 1 minus 2 times minus 2 is what? Positive 4. So 1 plus 4 is 5. What is 3 to the 5th? So it worked.